see the next question in this series, question 8 to 4. We are supposed to write whether the following are false, and it's supposed to give some sort of justification. There are 5 statements. Let's start with the first one. Sine of bracket a plus b is equal to sine a plus sine b. That's not true. We cannot distribute the sign operator for individual terms. That's absolutely illegal. And we can cross-check, verify by taking some random values. Let's take A as 30 and B as 60. So what will happen on the left-hand side, we will have sine of bracket A plus B. So, and on the right-hand side, we have individual sine A plus individual sine B. So sine of 90, is it same as sine of 30 plus sine of 60? Let's cross-check, verify that. Sine of 90 from standard trigonometric ratio tables, it is 1. Sine of 30 is half. Sine of 60 degrees is root 3 by 2. Root 3 by 2 plus 1 half is not equal to 1. So we can say that this definition, this relation is not true. The first one will be false. How about the second one? The value of sine theta increases as theta increases. This one is actually partially true. This one is true between 0 degrees and 90 degrees. Let's quickly make a small table. Sine of 0 degree is 0. Sine of 30 degrees is half. So in decimal, it will be 0.5. Sine of 45 is 1 over root 2. So approximately it's 0.707. Sine of 60 degrees is root 3 by 2. Approximately it's 0.866. And sine of 90 is 1. So as you can see, as the angle increases from 0 to 90, the sine ratio angle also increases. So this is, in this context, I'm going to write true. However, it is not universally true. After 90 degrees, when the angle exceeds 90 degrees, let's say 120 degrees, 135 degrees, 180 degrees, it eventually drops. But here we are assuming that we are only considering the angles within the first quadrant, that is between 0 degrees and 90 degrees. So within that context, this statement is true. So I'm going to write second statement as true. We can verify the cos ratio in a similar manner. Let's make a quick list of cosine values. Cosine of 0 degrees is 1. Cosine of 30 degrees is root 3 by 2, which is approximately 0.866. Cosine 45 and sine 45 are same, 1 over root 2. That's approximately 0.707. Cosine 60 degrees is half, and cosine 90 degrees is 0. So as you can see, as angle increases, cosine ratio generally decreases, and it is especially true if the angle is between 0 and 90 degrees. So this will be false. What about the fourth one? Sine theta is equal to cosine theta for all values of theta. Well, for all values of theta, it's not true. For very specific values, let's say if you take theta as 45 degree, then sine 45 degree and cosine 45 degree is both 1 over root 2. But that's very specifically true for 45 degrees. Can we say that it is true for all values? Absolutely not. So I'm going to say sine theta and cosine theta, they are, that is true only for a few values of theta. Sine 45 or cos 45, both are equal. But for other values, this is not. So I'm going to mark this as false. And cot A is not defined for A equal to 0 degrees. This one, let's see from the fundamental definition. Cot, instead of taking cot, I will first go for the tan. Tan is actually sine over cos. And since we know cot is a reciprocal of tan, so I'm going to say cot of theta is 1 over tan theta. So all I have to do is like flip numerator with denominator. So that would be cosine theta divided by sine theta. Now for a specific value of an angle A, which is 0 degree, cosine of 0 is 1, but sine of 0 is actually 0. So cot of 0 is 1 divided by 0. And we not defined. Division by 0 is not defined. So I will say cot of A, while it is defined for all other angles, but for A, this is not true.